but we're going to introduce it just in case some people want to use it. What I mean by getting around it is that you can manipulate the situation where you'd actually use Pythagorean theorem and then theorem 8.2 instead of using this one, because a lot of people forget about this one or think this one's a little harder. So as you can see, a lot of words in this one. But again, if you want to write it down, this is the leg theorem. So the first thing that you got to think about is in a right triangle, what's my leg? The what? The not, okay, the A and the B, that's a good way of saying it, right? So if this is my right triangle again, and we call this C, right? And we call this A and this B, my legs would be what? BC and AC, right? Okay? So again, it says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. So it's a lot like what we did yesterday. So here's my altitude. Why is it an altitude? Because it makes a right angle, right? And we call this, again, letter D. So just like what we did yesterday. Yesterday's, it said that this altitude was the geometric mean between this piece and this piece, right? Well, the leg theorem says, so if you want to read the words, it says the length of a leg of original right triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Weird, right? So, again, what it's saying is this. Let's say that we have this as x right over here. And we said that the entire hypotenuse is going to be called, let's stay consistent and say little c. So if you really wanted to come back here and be consistent, we could call this little a if you want. You want to do that? I don't care. But c is my whole entire hypotenuse. So what this is saying now is that x would be the geometric mean because it is the length of one of the legs. One of the legs, right? Is the geometric mean, so it has to be diagonal across from each other, to the whole hypotenuse, which is C, and then to the adjacent part of the segment. So let's call this K. Let's call this M. So the entire hypotenuse to, and then with K. So see how these two are like adjacent to each other? So you could say it as BD, yes, for K. Little k would be BD. Little x would be CB, if you wanted to write it that way. So then if we threw in another letter and said this was Z, we could do it the opposite way, right? We could say Z, because now it's the other leg, is the geometric mean between, again, the hypotenuse, which is the whole leg, and the side that's closest to it. So in this case, little m or DA. DA. So again, if you don't like the little letters, yeah, you can go back there and put them in there. This would be CB. This is CB. And then K would be BD. I don't know which way is easier. And then this would be BA. You can do it that way too. Okay? So then Z would be really AC, which is my leg. C is still BA or AB. And now N is AB. So you can do it either way. But again, like I said, you can kind of manipulate the situation where you don't honestly use this. And we'll show you that in just a second. Okay? Questions here? So here is an example of this. So remember we did this one yesterday, I believe? Yes. And we used theorem 8.2 to find E. Well, in this case right here, we're going to use the same problem, but let's just say they didn't tell us to find E and D. So most of the time when they don't tell you to find E and D, you're not even going to think about E and D. So let's try to block that out. And they're going to tell us to find C. All right? So one way that I can do it is doing exactly what I did yesterday and finding that altitude first and then just doing Pythagorean theorem. But like I said, a lot of times people, if there's no letter there, where I blacked out the E there, then they don't think about it. So now, if they tell me to find letter C, basically we're doing the proportion that revolves around the Z one. So Z is really C, right? Because C, the length KL, is the leg of my triangle. So again, my C would be the geometric mean of, what is my hypotenuse? 30. That's again where some people just kind of get going too fast and they don't realize that I got to add those two numbers. So then I'm going to take 30, and Brandon said the segment closest to it is 24. And then we would just do our math. So that's using that problem right there. Or using theorem 8.3 for that problem right there. Okay? Realistically, if we went back and did what we did yesterday, right? Yesterday, if you were given this problem, we did what? We did E was the geometric mean.
We did 24.
And then 24 and 6. Everybody remember that? And so then if they actually ask us to find C, I'm going to probably do this. I get my E, and then I'm going to use Pythagorean theorem to find my C. But what was E in this circumstance yesterday? Do you remember?
It was 12.
Was it 12?
Yeah, 12.
So E squared was equal to 144, and then E was 12. So again, it's not a big deal if I had then 12 squared plus what? C squared is equal to 24 squared. Right? That's how I would find C also. I could either do this form or I could do this form.
Would you put your C squared on the outside?
Did I put it in the wrong spot?
Yeah.
C squared.
12 squared.
No, because, so this is the weird thing, right? Is C my hypotenuse? Yeah, it is. You're right. Because I'm looking at the small one, right?
Yeah.
You're right. So let's move this.
Because the right angle, you have to go across the right angle.
Right.
So let's see.
24 squared and then C squared. You're right.
Oh.
Okay? Now, even though that we didn't do the answer, what should C be compared to these two?
Greater.
It should be at least bigger than 24. Right? If you find out that C is 17, you know you did your math wrong. Right? Because it's got to be the hypotenuse. Okay? And then, obviously, if we went back to find D, then you would just go and use Pythagorean theorem again with 12 and 6 in this case. And then again, remember what we talked about at the end, right? If that was the square root of 143 instead of the square root of 144, where we're making 12, just use the square root of 143 through the whole problem. Okay? The last thing that I want to look at is the problem in the book. Does anybody have questions with this? Either one of those. Now, I honestly don't know if you can see this problem, so somebody open your book to page 540 and see if there's a problem at the bottom. Okay. What?
Word problem.
It's a word problem, yes. So it starts with a community center?
Yes.
Okay. Everybody open your book. So again, remember when you were always asking, well, how am I ever going to use this in real life? Here's the situation. Now, are you going to actually remember to do this in real life? No. Probably not, unless it's tomorrow maybe. Right? Because if it's tomorrow, then you'd be like, hey, this is kind of what we did. But honestly, you probably aren't going to remember this, but I'm just going to show you that it's true. So read it out, or read it, right? A community center needs to estimate the cost of installing a rock climbing wall. And they need to know what the height of the wall is. Okay? So what they're saying here is, if you read the rest, it says, Sue holds a book up to her eyes so that the top and the bottom of the wall are in line with the book edge. So basically what they're saying is if you took a book and you put it like this, and extended your book this way and extended your book this way, with the wall, you're going to make a what? A right triangle. Okay? So that's what the concept that they're trying to put in. And so if you look right above it, they do this with the stadium stairs right above it. See where that guy is holding that book and then he's doing that stadium stairs. So you're using this kind of principle of forming this triangle to try to figure out the math. So basically, if I was going to do this problem, I'm going to draw a straight line here, and that's going to be my what? My wall. Okay? Then I got a person here, and they're holding the book. Okay? What does it say about the person if you continue reading that little paragraph?
Eye level is 5 feet above the ground.
Okay, so if their eye level is 5 feet above the ground, where does 5 feet go?
It's your altitude, technically.
So remember, what's the concept we're trying to use? We're trying to use this concept right here, right? And this is a right angle, right?
Yeah,
So where is 5?
straight across.
Are you sure?
Wait, from her eye.
Read it one more time.
For
Her eye level is 5 feet above the ground. She
ground.
stands 11 feet from the wall.
Okay, so she's 11 feet from the wall.
Yeah.
What's 11 feet signify?
Yeah.
The altitude. She's 11 feet from the wall. Okay? So where does the 5 go now?
On the right. About
Yeah, the 5 is this little section right here.
Okay.
So what do we need to find if we want to know the height of the wall? We need to find this spot right there, right? So which one are we going to use? We're going to use 8-2 from yesterday, right? Where Brandon said we're going to use 11 as the geometric mean.
Then 5 times x.
And then 5 and x. Now, what's the answer? So if this is what?
121.
121 divided by 5. Somebody punch it in your calculator. I think it's 24 or something. If I remember right. Okay? Is this my answer?
No. You got a minus by 5.
I got to minus it by 5?
Add 5.
I got to add 5. Who's right?
Adding
Because what do we want?
the whole thing.
We want the whole entire wall. So if this is approximately, and I don't remember what it was, but I'm saying this.
That's correct.
Yeah, that's correct.
Then we're going to add those two together, and my wall is 29.2 feet high. So again, are you really going to think about doing that? No, but it's actually kind of an interesting concept if you think about it. So you can realistically do this anywhere that you're at.
Why would you do 11 and not x? I thought we were always doing x's and stuff as
Because
No. In theorem 8.2 it says the altitude is the geometric mean. So whenever they say is the geometric mean, that number's got to be diagonal to itself. So in the first problems that we did, they gave you the 2, but it says find the geometric mean. So that's where the x's were across the picture. And that's what you'll do for today on your assignment. Okay? That makes sense? So again, like I said, I don't know if you'll ever use that, but it's kind of an interesting concept. Okay? Questions? So I get the rest of the time to work. Ginormous.
it is huge.
No, it's not.
90 problems.
There's a lot of them. This one's worth, these are all worth 3. This one's worth 3, so this one's worth 2. Oh, notice here, I don't think the directions say it in the book, but round answers to 1 decimal place are 70 through 73. You can honestly do that for all of them. And the ones above that, if you get a radical answer, I would just leave it as a radical. But reduce your radical. So you got to do that thing that we were doing yesterday on the board. Yes, now I think everybody can get it done. Okay? Thank you.